5.4 is probably one of my favorite sessions because it's actually one of the easier lessons. Kind of uses all the stuff that you've already been working on and just kind of ties it all together. And there's two actual things going on here. The first one is the remainder theorem. If somebody gives you a polynomial or any kind of function like this, then asks you to find f of -2, they're asking you to plug in -2 into this function, right? -2 cubed, 3 times -2 squared minus 4 times -2 minus 12. And that's a lot of exponents and multiplying, blah, blah, blah. The remainder theorem says you ain't got to do this. The remainder theorem says if you'll take that number and put it in the box and do synthetic division with that polynomial, 1, 3, -4, and -12, if you actually skip a line, draw a line, and do synthetic division with this, drop the 1, multiply, add, multiply, add, multiply, and add, they're saying whatever you get as a remainder is what you would get as an answer right here. You would get the answer to be 0 if you did all this out. You'd get the number 0. It's just kind of a shortcut for plugging in to a polynomial. You can do synthetic division and it will give you the answer. It's just that remainder. So if they ask you, using the remainder theorem, find f of -2, plug -2. You don't change the sign on this because that's not a x minus 2. That's just -2. They want you to plug that in and use those numbers from the polynomial, whatever your remainder is. So your answer would be f of -2 is 0. That's it. That's how simple the remainder theorem is. So here's the next problem. The directions will say use the remainder theorem to find the what g of 3 is. You're going to put 3 in the box. And instead of plugging 3 in, we're just going to do synthetic division using that. So drop the 1 and go. That's 3, -1, -3, 4, 12, 1. G of 3 is 1. That's pretty easy stuff right there. Yes? That's why we're only doing 2 examples for the remainder theorem on that. The remainder theorem, just plug that number into the box and solve from there. The second direction is going to say find the zeros of the polynomial. Remember, zeros is the same thing as solutions, x-intercepts, roots, all that stuff. So we're going to find this. Now, we're going to use synthetic division to find the zeros of the polynomial. We know the polynomial is 1, 3, -4, and -12, and we need a number to go in the box. And the way that we're going to know if we have the right number in that box is we're going to end up with a 0 as the remainder right there. Okay? So right now, we're going to start off with a -2. Now you may be asking, hey, where did that -2 come from? We'll figure that here in just a moment. Let's drop the 1, multiply, it gives you -2 and add. 1 times -2 is -2 and add. -6 times -2 is a +12 and gives you 0 as a remainder. That means that -2 is a 0 for this function. So when they ask me for my zeros, I'm going to list them. One of them's a -2. Now because the highest exponent's a 3, I know I'm supposed to be able to find 3 zeros. So I got to find 2 more. Where am I going to get those from? I'm going to get these from the answers. Remember, that was actually the third. This is now x squared. I'm dealing with x squared plus 1x minus 6. And if I set that equal to 0, because that's a quadratic, I can factor this. And that gives me plus 3 and, nope. Yeah, plus 3 and a minus 2, right? Yeah. So my other zeros are -3 and a +2. There are my 3 zeros. I found them. If I can get the cubic to come down to a quadratic, I can just set this equal to 0 and we know how to solve x squareds. We could do factoring, quadratic formula, completing the square, whatever else. Factoring is always the easiest if it would work. But the question of the day must be, where did the -2 come from? And the answer to that question is, I guessed it. You are going to have to guess numbers that are going to go in that box until you find something that gives you a 0. If you had started with any number other than -2, 2, or -3, you would not have gotten a 0 in that box for the remainder. If you would have started with a 1 or -1 or 5 or 17, it doesn't matter what number you plug there, these are the only three that would give you a 0. If you get something that's not a 0, it doesn't mean you're a bad person, doesn't mean you should quit and die or anything like this, or it definitely doesn't mean you should shoot your math teacher. It simply means try another number. Now the good news is there's a way to limit the number of guesses that you have to worry about. We'll talk about that in just a moment, okay? So here we go. On this next problem, if I have this, don't forget, you're looking for powers if they're skipped any. So to do this, it's 1, 0 for the x squared that's missing, -13 and 12. And I need to find a number that goes in the box. If I try the number 2, let's try the number 2. Drop the 1. 1 times 2 is 2. 2 times 2 is 4 and -9. -9 times 2 is a -18 and -6. Notice I did not get a 0 in the box. That just means that 2 is a bad number. No big deal. Start over. 1, 0, -13, and 12. And let's try another number. Let's try the number 3 because I know it's going to work. If I drop the 1, 1 times 3 is 3 and add. 3 times 3 is 9 and add. -4 times 3 is a -12 and add. I got a 0 as a remainder. That means when I'm writing my zeros, one of them is a +3. I should be able to find 2 more because this says I'm going to have 3 zeros. So one of them is going to be a 3. How am I going to find the other 2? Take the answer down here. It was x to the third. Now it's x squared plus 3x minus 4. And I'm going to set that equal to 0 and solve. Just by factoring bx plus 4 and x minus 1. So my other zeros are going to be -4 and a +1. Those are my 3 zeros right there. I'm curious why zeros is spelled, you just put an S on it, but the word hero, to pluralize it, you put an ES. Just curious. Oh, English is such a weird language. All right, any questions about that? Doesn't matter, I wouldn't be able to hear those questions if you got any. Let's go to the next example. Now, the question is probably brewing in your head, what numbers should I try? Am I just going to pick every number until I find one? Well, the answer is no. One of the parts of this lesson they're going to ask you for is not to find the zeros, but the possible zeros. In other words, what numbers are even good guesses? Well, to do your possible zeros, it will always be the factors of the last number divided by the factors of the first number. Since this back number is a 5, the factors of it are 1 and 5. The factors of the front number are, since it's just a 1, it's just 1. So the factors for that are going to be 1 divided by 1, 5 divided by 1, and you have to do a plus or minus in front of each of those because it could be a +1 or a -1, a +5 or a -5. What we're saying is there are only 4 possible rational zeros. Now there could be some imaginary ones. There could be some irrational numbers that won't work out by this. But these are the ones that you would start off by guessing. It's starting with a 1, -1, 5, -5. Okay? So let's start off with a 1. If they ask me to go ahead and find the actual zeros, then I'm actually going to try to plug some numbers in. The possible zeros would be a list of numbers. This one I've only got to try 4 of them at most. And, I might find one a lot earlier. Take the numbers 1, 5, -1, -5. Skip a line, draw a line, drop the 1. 1 times 1 is 1. It gives you 6. 6 times 1 is 6. Gives you 5. 5 times 1 is 5. Gives you the 0. That means 1 is one of the zeros. To find the others, I'm going to take this number here, this answer. That was x to the third, so now I'm down to x squared plus 6x plus 5. Set it equal to 0 and solve. that factors to be x plus 5 and x plus 1. So your zeros are -5 and -1. In addition to the one that you just found doing synthetic division, those are your 3 zeros. Okay? So far, so good. So here we go. So for this one, if they ask for your possible zeros, this can be the factors of 4 divided by 1. Since it's divided by 1, it's really just the factors of 4. So it's going to be plus or minus 1, plus or minus 2, plus or minus 4. Factors mean things that divide evenly into that number. So 1 divides into 4, 2 divides into 4, and 4 divides into 4. So on this one, I've only got 6 numbers total I can try. +1, -1, +2, -2, +4, -4. Those are the only options I've got. Okay? For this problem, I'm going to start off with a 1. Bring down a 1, -1, 4, and -4. Skip a line, draw a line, drop the 1. 1 times 1 is 1, gives you a 0. 0 times anything is 0. 4 times 1 is 4, gives you 0 as a remainder. That one worked out. So my zeros, my first one, is 1. I got to find 2 others. That was x to the third, so that goes in front of x squared. 0x, I don't have to write, plus 4 equals 0. Now, be careful with this one. The signs will mess you up. This one does not factor. If that was x squared minus 4, it would factor to be x plus 2 and x minus 2. It would be a difference of squares, but this is not a difference of squares. So for this one, I'm going to have to solve it a different way. Since the middle term's gone, I'm just going to sit there and move that 4 to the other side. Take the square root of both sides. Don't forget, when you take the square root of both sides, it puts a plus or minus there. And do the square root of -4. So that's a plus or minus. What's the square root of 4? It's 2. And the square root of a negative makes it imaginary. So my zeros are 1, positive 2i, and negative 2i. Those are my 3 zeros. Now, I wrote it like that just to remind you, because you have an x to the third, I have 3 zeros. You could have written it as 1 and then plus or minus 2i, as long as you put a comma between the 1 and the 2, the plus or minus 2i. Because it is different if you write it as 1 plus or minus 2i. That's different. But if you put a comma there, that's 1 is an answer, positive 2i is an answer, negative 2i is an answer. That would work also for your zeros. Okay? Just because something doesn't factor does not mean you do not have to go find that 0, okay? So here's the next one. The possible zeros.